0 and liftoff.
One of the most challenging aspects of this mission happens before we even land, and it's picking the right landing site for the mission. We want to study the habitability of Mars. We want to really figure out if it was ever capable of supporting life. And the way we do that is to really follow the evidence of water on Mars. One of the most interesting things about Mars is that it's changed over time. What we see on Mars today is very different from what occurred in the distant past. And water is the real interesting thing that we're looking for, the history of water, how it's changed over time. One of the biggest challenges to studying habitability on Mars, which is the goal of the Curiosity rover mission, is to try to follow that signature of water. Where was the water? How long was it there? And where do we go to look for evidence of it? If we were somewhere like this, where there's a pretty obvious geologic record of water flowing, carrying material down, that would be a home run. But the real challenge is finding that one spot on Mars to send this great rover mission to. We have 4 wonderful landing sites, all very different in character. And the real challenge for us as scientists is to come to a consensus on which one of those sites offers the best chance of fulfilling the goals of the mission. There's a place on Mars called Mars Vallis, which has the brightest mineral signature of clay minerals on Mars. And these clay minerals are known to form in the presence of water and neutral pH water, not acidic, not too basic, just the kind of water that would be friendly to life. Then you have terrestrial geologists who say that the rock record should be the thing that we follow, the landforms that look like they were carved by rivers or floods. So you have sites like Holden Crater, which is a big impact crater many miles across with a river coming into it, perhaps forming a lake multiple times and flooding the crater, leaving a geologic record that we can study with Curiosity. Just upstream a little bit from Holden Crater, there's a place called Eberswald Crater. That same river system in Eberswald has left evidence of a delta. Just like the Mississippi River Delta, these things form when muddy, silty water deposits its silt, its mud, into a formation, into a standing body of water, like a lake. And so you have people that study deltas on Earth who think that's the place Curiosity should go. The final site is the best place on Mars if you want to just study layered materials. So why do we like layered materials? Because just like this outcrop behind me, they give a record of time, of how things change over time. By studying different layers, you can rebuild the geologic history of Mars. So there's a place called Gale Crater, which has a 3-mile stack of layered rocks. Now we don't exactly know how those layers formed, and the mineralogical evidence isn't as strong as other sites, but people who just think layers are the thing to study really love Gale. So you have these 4 different sites and these 4 different groups and very passionate arguments back and forth to try to really narrow in on what is the one site to send the Curiosity rover.
Mission training for astronauts has always been rigorous. Testing our astronauts' limits, abilities, and knowledge is still an integral part of readying them for the tasks they'll carry out in space. In the Apollo era, there were so many more unknowns. Those pioneers used the best of what was available to them at that time and invented the rest. Safety was and is a top concern, but we push boundaries at NASA at great risk. Throughout NASA's history, technology has fueled the evolution of our training programs. Virtual reality allows our astronauts the benefit of safely repeating mission-specific events and activities, although some things we do don't look that different from back then. Astronauts have to be prepared for their journeys. It's the nature of all of those who explore.
Status check to proceed with terminal count. Atlas systems. Propulsion. Go. Hydraulics. Go. Pneumatics. Go. LO2. Go. Water. Go. Centaur systems. Propulsion. Go. Pneumatics. Go. LO2. Go. LH2. Go. ASGAS. Go. Electrical systems. Airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
Instrumentation.
Go.
Com.
Go.
GCQ.
Go.
Umbilicals.
Go.
ECS.
Go.
Redline monitor.
Go.
Quality.
Go.
OSM.
Go.
ULA safety officer.
Go.
Range, weather, and clear to proceed. Go.
You worked for years, some of us have worked for 5, 6 years to get to this point, and it always seemed like it was so far away, it was never really going to come. And what's amazing, when we came down here in June, it still seemed like it was a long way away. July, August, September comes and goes, and now you realize, wow, the number of weeks you can count on one hand.
See, I've had the privilege of working with the Mars Science Laboratory mission for the past 3 years, and I will dare say it's probably one of the coolest missions that I've worked on. Not just because of the science objectives, but the scale of the rover itself, the challenges that the team has gone through to try to meet the science objectives, to make sure that the payloads and the instruments operate as they should. The launch vehicle that we're using, the Atlas V 541, this is the first flight of a 541 launch vehicle.
What we do is we roll out the rocket from the vertical integration facility out to the launch pad. We use what's called a clean launch pad approach, and we do that 2 days before the launch. At that point, we connect the rocket and the mobile launch platform to the launch pad, and that's how we're able to load our liquid oxygen and liquid hydrogen on board, and actually made up the electrical connectors that have to power up the rocket and the spacecraft while it's at the pad.
Certainly we're confident in our systems now, but we keep checking them. We have continuous and a series of predefined tests that we do to make sure that the launch vehicle is communicating correctly with the spacecraft.
There's a million operating components there, and they all need to work all simultaneously.
You don't want any glitches when you get down to just a week before launch. The planets align only every 2 years, and you only get about a 3-week window. So if you're not ready to launch, the planets move out of alignment and you're waiting another 2 years. So it's very critical that we don't have anything that would delay our schedule and make us miss the launch opportunity.
Launch day, the weather doesn't look too bad. There is a front that's pushing through. It looks like Wednesday night, Thanksgiving Day, it should be pushed south of us, or at least south to central Florida. A bit breezy for roll on Friday, but we should have decent weather. Maybe a threat of an isolated shower coming in with a brisk onshore flow. And that looks similar to Saturday. It looks like the winds decrease just a little bit on Saturday, but anytime we're that breezy with easterly flow, would expect to see some kind of clouds coming in from the Atlantic with the threat of an isolated shower. So that's the principal concern it looks like right now.
LC, this is the LD on channel 1. LC, you have permission to launch.
Roger. Proceeding with the count.
T-minus 10, 9, 8.
7, 6, 5, 4, 3, 2,
1.
Am I confident that she's going to go and she's going to be successful? Absolutely. It's going to go and she'll be good.
Right on.
It is the stated policy of this administration and the United States of America to return American astronauts to the moon within the next 5 years.
Our agency, NASA, is going to do everything.
AA2 launch abort system.
We are wrapping up the last of the vehicle test and get ready to make it a real spacecraft here before too long. It's going to be a big push, but that's kind of how the end game goes. We try to get things ready, and every last thing has to be done and done right. It takes a lot of time and a lot of effort to do it.
We have a lot of work to do in the next 2 months because although the vehicle is in Florida and we've stacked it together just in the last couple of days, the rover's got its rocket jetpack on it, and the jetpack and the rover together have been put in the back shell of the vehicle, and right now we're putting the cruise stage on top. In some sense, that process is actually pretty straightforward. The challenge we have here in Pasadena is finishing up all our testing. All of our testing in our test bed and on the equipment, and going through and looking all the problems we had in our test program, make sure that all the problems we found were all solved and that we know what we're going to do and how we're going to fly it.
3, 2, 1, fire. Everyone stand by. Rover deck.
Testing is a lot like renovating your house. You can enumerate some very large, obvious things to do, and then when you do them, it becomes clear that there are some secondary things to do. And then when you do those, you discover third order, fourth order, ad infinitum. We require our system to be able to be robust, to survive a number of different kinds of faults, both internal faults, things breaking on the spacecraft, or loss of sun data coming into the sun sensor, a variety of unfortunate circumstances we try to make our design robust to.
Not only have we driven the rover, we've moved its arm, put it all through its paces, but it's been in a thermal vacuum chamber and kept very cold. Parts of it have been in a centrifuge. We've done drop tests, pull tests, drive tests, load tests, stress tests. Just an amazing amount of testing this vehicle has gone through. We've done shorting tests. We've taken the vehicle and shorted electronics. We've looked to see that the radios all work together and that the rover doesn't interact with itself in bad ways. We've tried every way of operating the vehicle using the software, literally thousands and thousands of hours of software testing. It's been just an amazing several years, really, of constant testing and development, finding problems, fixing those problems, and going on to the next problem.
The system is sufficiently complex that anything you change has to be done with great care and caution, and then tested thoroughly because of the potential for side effects, unintended consequences of the fix. The first rule of engineering this late in the game is do no harm.
This is a very, very complicated beast. This is by far the most complex thing we've ever built. It's almost hard to imagine how complex it is. And in fact, if you get close up to the vehicle, you can see the richness of detail. And in fact, this vehicle almost has fractal-like complexity. The more you look at it, the more details that you uncover. And yet to make sure, when you're building this thing and testing it and designing it, that those interactions are well understood and that there is nothing about the system that will interfere with itself. And this has been a real challenge that we've had. And so every minute of the time we've been using that time with incredible intensity. So hopefully we'll take a big breath in mid-November before we launch and be able to relax and let this vehicle off the ground and finally say goodbye. I think she's ready to go.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth. No single space project in this period will be more impressive to mankind or more important for the long-range exploration of space.
It began with those words from Kennedy Space Center's namesake, words that resounded throughout our nation, a call for exploration beyond our own planet. It was a challenge that put our nation on a path to the moon. Accomplishing that challenge began right here at Kennedy Space Center in 1962. And during the next 5 decades, this center would serve as the departure gate for every U.S. human spaceflight. Our space exploration journey began a few years earlier on Cape Canaveral Air Force Station, where launch pads were already beginning to line Florida's sunny central east coast during the late 1950s. Here, a group of 7 daring space pioneers were already preparing for missions to explore the heavens and learn to live and work in space. From 1961 to 1963, 6 successful manned Mercury missions were processed and launched from the Cape. The first up, astronaut Alan Shepard rode a Redstone rocket and Mercury capsule on the first U.S. suborbital mission, May 5, 1961, just 20 days before President Kennedy's bold speech to Congress. Not long after, February 20, 1962, John Glenn lifted off in the Mercury Friendship 7 capsule from Launch Complex 14 and became the first American to orbit Earth. After Mercury came Project Gemini, and Kennedy workers helped prepare the 10 manned missions that were flown on Titan II rockets during 1965 and 1966. Project Gemini helped develop skills in rendezvous, docking, and working outside the spacecraft, skills that would be critical in flying to the moon during Project Apollo. Before the Gemini missions came to an end, though, a moon launch facility was starting to take shape at Kennedy Space Center. A spaceport was unfolding, ready to meet the goal of launching rockets to the moon and probes to investigate the far reaches of our solar system. An energized workforce stood ready to tackle any challenge on the horizon. We built the Launch Complex 39 launch pads and the giant vehicle assembly building designed for the Apollo missions. The 525-foot-tall VAB was the largest building by volume in the world. With 4 massive high bays, work platforms, and large cranes, it was a structure fit for processing the mighty Saturn V rocket that would soon take the dreams of a nation to the moon. Several Apollo missions launched from Kennedy, setting the stage for the main event. It was Kennedy Space Center's managers, technicians, and engineers who helped prepare the Saturn V rocket and Apollo 11 capsule for the launch to the moon, July 16, 1969.
Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
Thousands flocked to witness history. An estimated 530 million people watched on black and white televisions as the Eagle landed. They heard Neil Armstrong's words as he became the first human to set foot on the lunar surface, July 20, 1969.
It's one small step for man, one giant leap for mankind.
During the 70s, Kennedy's workforce prepared some of the most sophisticated machines of the day, robotic probes with computer brains, cameras, and instruments that would return information about distant worlds. These included the Pioneer and Voyager spacecraft that launched aboard powerful rockets from the coast of Florida and traveled to distant planets and are on their way beyond our solar system. Following Apollo's final lunar landing in 1972, launch of America's first space station called Skylab in 1974, and the first international handshake in space during the Apollo-Soyuz test project in 1975, we focused on the future at Kennedy. A new program with new goals for space exploration was beginning to ramp up, the Space Shuttle program, featuring a vehicle that launched like a rocket and landed like a glider. And with it, Kennedy Space Center emerged as a place of adaptation and innovation, leaders in rocket ingenuity once again. The first of NASA's fleet of space shuttles, Columbia, arrived at Kennedy in 1979. Inside the orbiter processing facility, a dedicated NASA and contractor workforce spent 2 years and thousands of hours preparing Columbia for her maiden flight. On April 12, 1981, Kennedy and the country launched a new era of spaceflight.
America's first space shuttle, and the shuttle has cleared the tower.
Each liftoff of Space Shuttle Columbia and then Challenger, Discovery, Atlantis, and Endeavour etched an indelible mark on scientific discovery and research, pushing boundaries and accomplishing more than before. For 30 years, the space shuttles carried hundreds of astronauts who lived and worked in space. Shuttles placed innovative Earth-observing and interplanetary explorers into orbit, like Magellan, the first planetary spacecraft launched by a shuttle. Galileo, deployed by Atlantis on a 6-year journey to Jupiter. And the Hubble Space Telescope, which revealed a colorful and active universe never seen before. But with great triumph in our 50 years of space accomplishments came great tragedy. An accident on Pad 34 took the lives of the Apollo 1 crew on January 27, 1967, and later 2 shuttle crews. The world was saddened when we lost the crews of Challenger in 1986 and Columbia in 2003. Left behind was a Kennedy workforce of thousands, committed to safety, who returned the shuttle fleet to service to one day complete the International Space Station. Our legacy of being the world's premier launch facility continued.
Systems armed, T-minus 10 seconds, go for main engine start. 7, 6, 5, 3 engines up and burning. 3, 2, 1, and liftoff of Space Shuttle Discovery, beginning America's new journey to the moon, Mars, and beyond. And the vehicle has cleared the tower.
For more than a decade, Kennedy Space Center's Space Station Processing Facility workers prepared many of the parts for the orbiting outpost, including all of the solar arrays, the Destiny Lab, multi-purpose logistics modules, the Alpha Magnetic Spectrometer, connecting nodes, and the cupola, the station's window to the world. Our country and the world are reaping the benefits of this orbiting laboratory as it reaches its full potential in research and technology. It will be the centerpiece of human spaceflight activities for many years to come. And while the space station came together, Kennedy Space Center's Launch Services Program continued NASA's tradition of innovation and discovery with successful rocket launches that increased our understanding of Earth, other planets in our solar system, and the deep space beyond. This skilled NASA and contractor team has supported the launch of an impressive collection of rockets and spacecraft, including the Mars rovers, searching for clues about life on the red planet, Kepler, which is investigating planets like our own, and the triumphant touchdown of Curiosity, ready to explore the habitat on Mars. The Launch Services Program is Earth's bridge to space, continuing to launch spacecraft and satellites aboard powerful and sophisticated rockets from the east and west coasts. In 2011, The last 3 space shuttle missions were successfully launched and landed, completing 30 years of remarkable service.
Having fired the imagination of a generation, a ship like no other, its place in history secured, the space shuttle pulls into port for the last time.
Now, as we successfully did after Apollo, the center is transforming itself once again by updating and preparing the facilities to support a new generation of space launch vehicles. The massive vehicle assembly building is undergoing a renovation to accommodate several different launch vehicles at once, including NASA's Space Launch System. Launch Pad 39B is now a clean pad that can support many different types of launch vehicles. The Operations and Checkout Building High Bay has been totally renovated for processing of the Orion spacecraft that will carry humans into space and beyond low Earth orbit. During the past 50 years, Kennedy Space Center and the people who prepared NASA's missions and readied its vehicles shared in the excitement of each launch. They built a legacy of ingenuity, innovation, safety, and success. We are, the world's leaders in launch engineering, building on the past, yet standing ready for the future. Look at everything we've accomplished, and we're just getting started. Our nation's space exploration adventure will continue at the place where it all began, Kennedy Space Center.